All right. All right. Good afternoon, all. How about my audio online students? Am I audible? Is it clear and loud? How's it? Online students, what about the audio? Am I audible, clear and loud? Okay, right. Okay, so as we have planned, today we are starting the next part in waves, that is stationary waves, right? That is stationary waves. So far in oscillations and in waves, we have covered simple harmonic motion. That was the first part we had in oscillations, right? So under oscillations, that was simple harmonic motion and that was covered. And then from waves parts, last month we covered wave phenomena like reflection, refraction, diffraction, interference, polarization. So such wave phenomena were covered, right? And today we are starting stationary waves, so it is also called standing waves, right? One of the most crucial parts when it comes to questions, because very regularly, very frequently questions are coming from stationary waves, right? And during the month, other than stationary waves, we will be covering Doppler's effect and intensity levels, right? Those are the other two parts coming up in waves, under waves, and that's a plan during the month of October, right? So today we are starting the first part there, stationary waves, right? So coming up, we'll be covering Doppler's effect plus intensity levels, right? Okay, and the other thing, as I informed you since 2 weeks, now today onwards, we are going to have the class up until 7:30, right? With the extension, with an extended hour. So we'll be having the class until 7:30, right? Until 7:30. And around 6, I'll be giving you a small break. So now, as usual, we are starting at 3:30 and up to 6, up to the interval, we'll be doing the class as usual. And then I'll be giving you a break, a small break around like 15 minutes, right? 15, let's say 15 minutes, around 6. And after 15 minutes, again, you have to come back to the class, and then it will be continued. It will be continued until 7:30, right? So that is the plan for the class today onwards. That will be the plan today onwards, right? Okay, and the other announcement, since some of you have asked about the paper class. So as planned, we are starting the paper class on 6th of October. That's coming Monday, right? Coming Monday. And yeah, I saw some of you from the regular students from the class were already enrolled by now. Now, the announcement is to the students who are willing to join and who are not enrolled yet. Since paper class is registration of paper class and the enrollment of paper class is going as a different class, right? You have to go to the website again and complete your enrollment if you are joining the paper class, right? So you can go to the website in the same manner, and in the available classes, you will see the paper class there. Just come in. And if you need to enroll, this is the enrollment key for the paper class. So you can just enter this and enroll to the class. PS at capital P, simple HY, 26P. Right? This is the enrollment key. So if you enter this enrollment key, you can do a self-enrollment. Right? You can do the self-enrollment. Right? The regular students, since you have already created the accounts and you are already using the website, you just need to enroll to this class. Right? So I saw some of you were already joined in the sense enrolled. Right? So don't wait until the last moment, because we'll be starting on Monday. Now in the free time, you can take some time, and this won't take even like 20 minutes, 20 seconds, right? This won't take even 20 seconds, right? Just go there and click on the class, and you will be asked about an enrollment key. So enter the enrollment key and you will be enrolled to the class, right? So if you are willing to join, complete the enrollment, don't wait until the last moment, right? Okay, right. So first day onwards, you have to log into the class using the website. So therefore, it's better to complete your enrollments beforehand, right? Okay. And first day onwards, you are going to start writing questions, start writing papers. So therefore, now still you got like 4 days before starting the paper class. Go through the notes again and familiarize yourself with the part we have already covered, because now starting from first day, you are starting writing papers, right? So I'll say the exact plan of the paper class. I'll explain everything on the starting day of the paper class, right? Yeah, and some of the students asked about the verification email thing. Now, if you are trying to create the account, if you didn't receive the verification email instantly, verification email comes instantly. Instantly means during like 1 second, 2 seconds, it comes, right? So if you didn't get the verification email, that is because the email is not in the inbox. If there is not in your email inbox, that is definitely in your spam box, right? In some email accounts, since you are getting an email for the first time from an unrecognized domain, unrecognized address, sometimes it is sent to the spam box, right? So if you go to the spam box, you will see the verification email, right? So keep that in mind. Once you try to create the account, if you didn't get the verification email, please check the spam box as well, right? Definitely it should be there in the inbox or the spam box, for sure that's there, right? Okay, so I just said because few students asked about me about not receiving the verification emails. The reason was they haven't checked the spam box, because usually we don't check the spam boxes. No, we are just checking the inbox, right? But once the email is not there in the inbox, they are thinking that the email is not received. No, email has come, but the thing is that is in the spam box, right? Okay, then without further ado, we will start. Right now, today we are going to start stationary waves. As I explained before, stationary waves. So far in the last month, we have covered the wave phenomena, and the previous thing was simple harmonic motion. And then last month we have covered wave phenomena. And today we are going to start stationary waves, right? Okay, first take down the heading, then we'll see what stationary waves are and what is so special about stationary waves to learn as a separate part, right? Okay, take down the heading, stationary waves. Stationary waves. And this is also called standing waves. This is also called standing waves. This is also called standing waves. Stationary waves or standing waves. Stationary waves or standing waves. Okay, look at the board. Look at the board. We know normal waves in the sense they are actually called progressive waves, right? Progressive waves are propagating like this. Progressive waves are propagating like this with the wave pattern. Progressive waves are propagating like this with the wave pattern, right? And if we have two identical waves, listen, if we have two identical progressive waves which has same phase and same frequency, but they propagate in opposite directions, right? So we know the superpositioning of waves, right? When they propagate in opposite directions, two waves will be superpositioned each other, right? Falling on each other. That is called superpositioning. So after being superpositioned, the wave will be like this. After being superpositioned, the wave will be like this, right? Something like this. After being superpositioned, the wave will be like this, right? Now, one wave travels in this direction, while the other wave travels in the opposite direction like this. Right? Now, when this keeps happening, listen, when superpositioning of two identical waves which travels in opposite directions overlap each other, when this keeps happens, this resultant wave is called a stationary wave. Right? This resultant wave is called a stationary wave. Correct? Now, there are more examples for stationary waves, right? We'll see in the coming up parts, like in strings we have these stationary waves, in wires we have, in tubes, pipes, right? So there are different cases. There are different scenarios where we have stationary waves, right? Now, basically, this is the formation of a stationary wave. So therefore, stationary wave is a result of superpositioning of two waves of same frequency which propagates in opposite directions, right? So don't take this down, don't write this down, don't take this down, just write down this first. Write down a stationary wave, write down a stationary wave, a stationary wave is caused by a stationary wave is caused by superposition of caused by superposition of superposition of two waves, superposition of two waves of same frequency, superposition of two waves of same frequency and same amplitude, same frequency and same amplitude, same frequency and same amplitude, but opposite phase, PHAC phase. So we know what the phase of a wave is, but opposite phase, right? But opposite phase, within brackets, travels in opposite directions, right? So I'll draw this in a nice manner. Right here. So basically we call this a stationary wave. Right. And when it comes to stationary waves, there are special points on the wave to be identified, right? Just look at the board. Just look at the board. Right. Look at the board. Now we know when it comes to progressive waves means the waves which we have learned so far. Normal types of waves, normal waves. Progressive waves, they progressed as, they travel as crest and trough, or trough and crest and trough, right? But in this wave, we don't have trough and crest, right? Or crest and trough, right? Instead, what we have is nodes and antinodes. Listen, instead, what we have is two things: nodes and antinodes. N means nodes. A means antinodes. Nodes and antinodes. Nodes and antinodes. Nodes means the points with minimum displacement, right? And antinodes means the points with maximum displacement, right? Simple as that. Nodes are the points with minimum displacement, and antinodes are the points with maximum displacement, right? Now, if I identify these points in the wave, right? In the wave, it is like this. Now, at this point, the displacement is minimum, so that is a node, right? At this point, displacement is maximum, that is called an antinode, right? Again, at this point, minimum, node, antinode, node, antinode, node, antinode, and node. So likewise, when it comes to stationary waves, they travel as nodes and antinodes. They don't have crest and troughs because two waves are superpositional now, right? And stationary wave is the resultant wave, right? Now, we are not going to separate these two waves. We are not going to separately study or separately think of these two waves, right? Now, as the result of superpositioning of these two, a whole new wave is formed. A whole new wave is formed now, right? And that wave is the stationary wave. And in that stationary wave, we have antinodes and nodes only, right? For you to understand this better, I will show you a graphic as well, a graphical animation as well, right? So until I search for an animation, first take this down. Give me 1 second, I'll show you an animation. Can you see the board? Sorry? Node. Node is the minimum displacement. Minimum displacement. We will write everything in the node, so don't worry. Can you see the screen? See, now in this one, now this blue color and red color ones are the two waves which are propagating in opposite directions, right? These are the two waves which are propagating in opposite directions, right? And as the stationary wave, what we are drawing here is the impact of both. And below what you can see is the resultant wave, because with the superpositioning of the wave, a resultant wave forms, right? A resultant wave forms. But for our calculations, what we are drawing is the stationary wave, right? Now, just understand what is happening here from this animation. Then again, I will show you a clear one, a more clear one with the superpositioning like this, right? Now, this is what happens for these two waves. One wave travels in rightward direction, another wave travels in the leftward direction. And once both are superpositioned, a third wave, a resultant wave is formed, right? That resultant wave is actually called the stationary wave, right? Now, if I show you something like this, can you see? Now, tell me, what are the two propagating waves? You can see the colors, no? We have three waves in red, blue, and green. What are the two propagating waves here? Red or blue or green? What are the two propagating waves here? Red is the resultant. Red is a resultant wave. Red is a resultant wave. And what we have drawn here are the blue and the green wave, right? Blue and the green wave. And this is just a random position of the stationary wave when it propagates. This is a random position, right? Now, if you can stop this somewhere, see, give me 1 second. Now, if I can stop that somewhere, right? Something like this we will see. Something like this, right? So that is what we have drawn here. That is what we have drawn here. But in reality, that is not stop. That is always propagating. That is always propagating. So therefore, this is how it will be propagated, like this. Here, see. So this is how it's propagated. But for the calculations, for the questions, what we are drawing is a random position of that, a random position. Got it? Now in this case, the red color and blue color waves are the two waves which are propagating in opposite directions. And the black wave is the resultant wave. Right? We don't deal with the resultant wave for the calculations. For the calculations, we will be using the two base waves, two basic waves we have inside the stationary wave, right? So otherwise, this is the formation of a stationary wave, and this is what happens in reality, right? Is that clear? All right. Right. Okay, it's clear, right? Okay, now below this, first point with an asterisk mark. First point with an asterisk mark. Points with maximum displacement points with maximum displacement in the wave, points with maximum displacement in the wave are called antinodes. Points with maximum displacement in the wave are called antinodes. Now, if there's anything to clarify, you can always raise your questions via Zoom if you are on Zoom, and the YouTube students also. If you are on YouTube, you can forward your questions via YouTube live chat, so I can see both chat boxes from these two screens, right? So you can forward all your questions if you have anything to be clarified. Right, within brackets capital A, within brackets capital A, antinodes, within brackets capital A. Second point, points with minimum displacement, points with minimum displacement in the wave, points with minimum displacement in the wave are called what? Are called nodes. Are called nodes. Are called nodes. Within brackets capital N. Within brackets capital N. Right. Now, nodes and antinodes are defined based on which property? Based on which parameter? Now, I just explained in these 2 points. Nodes and antinodes are defined based on displacement. Yeah, minimum or maximum displacement. So, therefore, nodes and antinodes are based on displacements. This is based on displacement. This is based on displacement, right? Now, other than nodes and antinodes, again, there is another definition using pressures, right? Using pressures, based on pressures. Now, when it comes to pressures, this is how it's changing. Now, if we take a node like this, right? In a node, listen carefully, in a node, displacement is minimum. Displacement is minimum means pressure is maximum. Because from either sides, if there is pressurized, since there is pressurized, the displacement is minimum. So therefore, when it comes to nodes, their pressure is minimum or maximum. Their pressure is maximum. Their pressure is maximum when it comes to nodes. When it comes to nodes, their pressure is maximum, right? When it comes to antinodes, they are very much free to move, which means pressure is minimum, right? So therefore, nodes are also called pressure antinodes. Nodes are also called pressure antinodes because node means minimum displacement. There is a maximum pressure, no? So therefore it's called a pressure antinode. Right? And the other way, antinodes are also called pressure nodes. Pressure nodes. Antinodes are also called pressure nodes. Got it? Right? So therefore, both are used, and popularly we are using this one, nodes and antinodes, right? But sometimes in questions, without giving nodes and antinodes, you will be given the terms as pressure nodes and pressure antinodes. Then you have to know the difference, right? So they are exactly opposite. Nodes are pressure antinodes and antinodes are pressure nodes, right? Okay, don't write this. Just take this down as a note. Write down as a note. N-O-T, not a node, note. Take this down as a note. Take down as a note. First point, and under the note, first point, points with maximum pressure. Points with maximum pressure are called Pressure antinodes. Pressure antinodes. Points with maximum pressure are called pressure antinodes. Right? Within brackets, all nodes are within brackets, all nodes are pressure antinodes. All nodes are pressure antinodes. All nodes are pressure antinodes. Right? Next point. Points with minimum pressure. Points with minimum pressure. Points with minimum pressure are called pressure nodes. Points with minimum pressure are called pressure nodes. Points with minimum pressure are called pressure nodes. Within brackets, all antinodes are pressure nodes. All antinodes are pressure nodes. Right? So basically, the idea of these two words are actually minimum and maximum. Right? Nodes means minimum or maximum. Nodes means minimum. Idea of the word node is minimum. Right? Now, when the displacement is minimum, that is called a node. When the pressure is minimum, that is called a pressure node. The idea of the word antinode refers to maximum. Right? So that is how it goes. And then take this down and highlight. Take this down. This one. So then the resultant wave just goes up and down, not in the directions of other two waves. Yes. Only the base waves travels in opposite directions. Right? The resultant wave goes up and down. Now, it is usually between two fixed points. Then, in between 2 points, the resultant wave goes up and down in the sense, now there's a movement for the motion, for the wave, right? But the resultant wave is having an up and down motion like a transverse wave. So actually that's a transverse wave. Right. Okay, finished. Then as the next heading, write down next heading, differences between progressive waves and stationary waves. Differences between progressive waves and stationary waves. Differences between progressive waves and stationary waves. Right? So we will do this in a tabular form, in a table like this. Right? This side is progressive waves, and this is stationary waves. Right? Progressive waves are the normal waves that we have, like this, and stationary waves are the result of superpositioning of two waves like this. Sorry? progressive waves. So station is propagating as nodes and antinodes, right? Because in a station we have node points and antinode points. So they propagate as node and antinodes, right? Okay, so we'll do this on a table like this, right? And we are going to compare points one by one. We are going to compare points one by one, differences, comparison. Take it down. So yesterday was Children's Day, right? So did you celebrate? This is the last year you can celebrate Children's Day as a children, right? As children, right? So by next year you will be 19 years of age, which means officially you are an adult. You are still 18, right? 18. Still 18, right? So this year is the last Children's Day you can celebrate as a child, right? As a child. Now on the same day, both Children's Day and Elders Day occurs, right? But when we celebrate the Children's Day as a child, it's a different thing, no? Right? So until 18 years of age only you can do it, right? So if you didn't celebrate yesterday, which means you have missed the last Children's Day that you can celebrate as a child, right? Next year onwards, you can celebrate, you will be upgraded, you are upgraded to the Elders Day. Then you can celebrate the Elders Day, right? Okay, let's go one by one. First one, write down. First one, in progressive side, wave model exists. Wave model. First one, wave model exists. Wave model exists. Wave model. Exists. Wave model means, just listen. Wave model means the sinusoidal form of the wave. That is called the wave model. This one. This is called the wave model. The sinusoidal form of the wave, this one, it's called the wave model, right? So in progressive waves, wave model is there. But in stationary waves, we don't have a wave model, see? In stationary waves, we don't have a wave model, right? So in stationary side, write down, wave model doesn't exist. Wave model doesn't exist. Stationary side, wave model doesn't exist, right? Then number 2, in progressive side, this is number 1. Then number 2, in progressive side, energy is transferred. Energy is transferred. Energy is transferred along the wave. Energy is transferred along the wave. Energy is transferred along the wave. In stationary side, energy is not transferred. Energy is not transferred along the wave. Energy is not transferred along the wave. Energy is not transferred along the wave. Within brackets, mention this in red. Within brackets in red, energy is transferred by. Energy is transferred by. Energy is transferred by vibrating surrounding medium. Energy is transferred by vibrating surrounding medium. Energy is transferred by vibrating surrounding medium. energy is transferred by vibrating surrounding medium, right? So just know the difference. Listen, if I asked whether both types of waves transfer energy, what's your answer? Yes or no? Tell me. Do both types of waves transfer energy? Yes or no? Quickly. What about online students? I need responses. Yes. Yes. Both transfer energy. Both transfer energy. Because by definition also we know first day of waves. What was a wave? What was a wave? Definition of waves. First day. Right? Wave is a transfer of energy. Right? Using vibrations. Right? So wave itself is a transfer of energy. That's a form of transferring energy. That is how a wave is defined. So therefore, both waves are transferring energy. Progressive waves transfer energy along the wave, and whereas the stationary waves transfer energy by vibrating the medium, not along the wave, by vibrating the medium. Either way, energy is transferred, right? Because by definition, any wave is an energy. Any wave is a transfer of energy. Got it? Right. Third one in progressive side. Number 3 in progressive side propagates as propagates as what? When it comes to progressive, propagates as crest and troughs. Crests and troughs. Right? Progressive side, third one, propagates as crests and troughs. Propagates as crests and troughs. And in stationary side, propagates as what? Propagates as nodes and antinodes. Propagates as nodes and antinodes. Next point in progressive side, point 4 in progressive side, shortest distance between 2 points at same phase. Shortest distance between 2 points at same phase, PHAC phase, is lambda. So it is like this. These two are 2 points at the same phase. These two. See, these two are 2 points at the same phase. And this shortest distance between these 2 points is lambda. That's a wavelength. Right? Take this down. Right? Okay. Then the other side, stationary side, write down. Stationary side, write down. Shortest distance between shortest distance between 2 points, shortest distance between 2 points at same phase, shortest distance between 2 points at same phase is lambda over 2. Is lambda over 2. Lambda over 2. Right? Why is that? This is the reason. Now in a stationary wave, in a stationary wave, these two are the 2 points which are at the same phase, right? So therefore, this is not a lambda. This is only lambda over 2. This is only lambda over 2 of the wave. There is only lambda over 2 of the wave, because lambda is from here to here. If you compare with the progressive wave, lambda is from here to here, right? Now, when these loops are created, they are called loops in a stationary wave. Loops. When loops are created, loop is here. So therefore, the shortest distance is going to be lambda over 2. Only lambda over 2, right? So this is called a loop, right? You will see the jargon in the coming parts. They are called loops, right? So if needed, you can label here as well. They are called loops. Right? Then next one in progressive side. Next one in progressive side. Number 5. Amplitude at amplitude at any point is same. Amplitude at any point is same. Amplitude at any point is same. In the stationary side, amplitude is different from point to point. Stationary side, amplitude is different from point to point. Amplitude is different from point to point, even within the same loop. Amplitude is different from point to point, even within the same loop. Right? Next one, number 6. Number 6 is, listen, number 6 is not actually a difference. There is a similarity, right? So therefore, you can mention this sentence from here to here at once, right? With a red pen. Number 6, use a red pen and mention it as to cover both, because that will be same for both types of waves, right? Use a red pen and mention frequency is same. Frequency is same at any point. Frequency is same at any point. Frequency is same at any point of the wave. Frequency is same at any point of the wave. Frequency is same at any point of the wave. Right. Okay, close that table. Close the table. Close the table. Right. So moving on. As the next heading, write down. Equations for velocity of wave. Equations for velocity of wave in different media. Equations for velocity of wave in different media. Equations for velocity of wave in different media. Right. For this thing also, we'll be using a table. Right. So basically, what are the two main types of waves we have? Yeah, transverse and longitudinal, right? And what are the main types of media we have? What are the main types of media we have? Solid, liquids and gas, right? Solids, liquids and gases, right? So we'll do this way. And here, this is the type of the wave. This is the wave. And this is the medium, right? This is for transverse waves. And this is for longitudinal waves. And along these columns, we will mention the medium. First one, solid, then liquid, and then gases, right? Okay, take it down. Or shall I write the equations first? Then you can get an idea about what the space is going to take, right? Okay, now when it comes to stationary waves also, stationary waves are also a result of superposition of two waves, right? Then those two waves should be either transverse or longitudinal, right? So therefore, when it comes to stationary waves, we have stationary waves of both types. Stationary wave can either be transverse or longitudinal. Sorry? Longitudinal wave? Could hear. Yeah, that is coming up actually. Because in tubes and pipes, we have longitudinal stationary waves. In strings and wires, we have transverse stationary waves. So likewise, all the categories are there. Right? That's all about this thing today. Right? That's all about the stationary waves today. They are coming up, right? So just wait for another like 30 minutes, then you will see. Right? So the first idea you have to have here is, when it comes to stationary waves, the stationary waves are also formed due to the superpositioning of two waves. So therefore, you have stationary waves of both types. Stationary waves can be transverse or can be longitudinal as well, right? Because the basic categorization we have about waves is as longitudinal and transverse only, right? Stationary waves is a result of superpositioning. Stationary wave is a result of wave superpositioning. Got it? Right. Okay. So when it comes to transverse waves, look at the board first. When it comes to transverse waves and solid media, what about if I use blue? It's visible, right? Okay. So when it comes to transverse waves, solid media, right? There are two equations. First equation is V equals root T over M, right? We will explain what this T means, what this M means and everything, right? Second equation, V equals root T over OA, right? So quickly I'll write while explaining. T is tension of the string or tension of wire. M is called mass per unit length, not the mass per unit length, right? And rho here, density, A cross-sectional area. And when it comes to longitudinal waves in solid medium, that is V equals root Y over O. V equals root Y over O. Y is Young's modulus, right? You haven't covered Young's modulus yet because Young's modulus is coming up in unit 9 under elasticity. Just know the word, that is Young's modulus, that is about the elasticity of the medium. That is about the elasticity of the medium, right? And rho is density as usual, right? And when it comes to liquid medium, transverse waves, V equals root GH. V equals root GH. G is gravitational acceleration and H is depth of the medium. Can you remember I mentioned this equation, yeah, when I was explaining about shallow and deep mediums in refraction, right? Same equation. V equals root GH. And for A levels, we don't have longitudinal waves in liquid mediums. For A levels, for A levels, we don't have. In reality, we have. For A levels, we don't have. For A level physics, we don't have. Right? And when it comes to gaseous mediums, we don't have transverse waves. You have only the longitudinal waves. V equals root gamma RT over M. O V equals root gamma P over O. Right? Gamma is called ratio between specific heat capacities. Ratio between specific heat capacities. R for a gas medium is a very popular thing, right? R of a gas medium is universal gas constant. In P equals nRT, you have universal gas constant. Capital T, absolute temperature, M, molar mass, and P, pressure of the gas, rho, density of gas. Right? So these are the old equations we have. Listen, these are the old equations we have for velocities in different media in A-level physics. All the equations. That's why I'm mentioning all the equations at once, because in the coming parts you will see these equations based on different medium. Right? So therefore, you have to know all these equations prior to that part that is coming up. So therefore, from this part onwards, you have to know all these equations. And after closing this table, below the table, we will introduce all these terms below the table. You will introduce all these terms below the table. So therefore, have some space to introduce the terms as well. Now take it down. Now take it down. Another thing that I couldn't inform you is now, actually I got an inquiry just now, that's why this came to my mind. Now, in the previous days also, some of the students some of means few, very few of students have asked me about the study packs, the ones who were not there in the class from the beginning especially, right? They have asked me about the study packs and how to get the previous lessons and those kind of things, right? Now I had to wait until my website is finished. Now since it's done, now yesterday onwards, now study packs are available on the website, right? Now they are like lesson wise study packs, right? As an example, let's say you need linear motion, right? Linear motion and projectile motion, that's a single pack, right? You need linear motion and projectile motion. So in a study pack, once you get that study pack of linear motion and projectile motion, now in that pack, all recorded videos covering all the things in the lesson and tudes, and if there are any other study materials other than tudes, they are included. And other than that, if we have conducted exams using that particular part, exam papers are also included, right? So that folder is called a study pack, right? So I just inform in the class because now I got an inquiry just now, that's why it came to my mind. So if there's anyone who is in need, now you can visit the website and see now the packs are available, right? They are lesson wise packs are available, right? Sorry? Sorry? No, 6:30. Yeah. No. The above one, that is not about the wave class, that's the theory. And below, I mean, time is correct, no? 6:30 and 9:30. Isn't it? No? Let me check. No, this is stage and waves. Huh?
October 16th is the class.
No, that's the stage and waves class, right? And
for them, the other is
yeah. Then are you on the channel? About the paper class, this one. Correct? The class? On?
Online.
Yes, online.
So how do you write the paper?
When you are writing papers, you can write physically. Right? Discussion is online, right? But for the first day, since we are starting with the introduction session and introductory session, it will be online. But then onwards, if you are writing the paper physically, you can come to either of the two institutes here, or Leesa or any institute, then you can write the paper physically. Discussion is online, right? Discussion is online. And my coming up plan is to collect your papers if you are writing physically and grade them and mark them and give it to you before the discussion. That's a plan coming up, right? And for that, I might need a like team of 2-3 members, right? That we'll see how we can do it. I'm planning on it, right? I'm planning on it. So we'll plan for the best. Let's see. But this week when we are starting, since that is the first day, that will be only online. And then you have 2 writing centers if you are writing physically here or an institute. Okay. And I'm emphasizing again, if you were there in the live class for a particular lesson, don't purchase study packs. right? That is not for you. That is for the ones who have missed some part, missed some lesson, right? So if you have in the live class, if you have been there in the live class, now let's say for simple harmonic motion, you were there in the live class. And again, don't think of purchasing the study pack. Don't do it. Don't do it. If you are in the live class, which means you have everything like notes, the other things, all the discussions we had, you have, right? So in such a case also, if you are difficult, if you feel difficult to do the questions, right? Again, you can do is you can go through the note and practice the questions we have discussed in the class, right? So otherwise, don't think of purchasing study packs. That is exclusively for the students who are not there for a particular lesson, right? If you learn that with me in the class, don't purchase it, right? That's a waste, right? That is not for you. හරි නැත්තම් මේ හැමෝම එහෙම ගන්න එපා හොඳේ. ඒක එහෙම නෙමෙයි. ඒක ඕන කෙනෙක්ට විතරයි. ඒ කියන්නේ there are some students who join to the class, let's say after 4 months. Then first 4 months are sometimes missed. Sometimes they can request the recordings and get it, right? If not, sometimes it will be missed. So in such cases, there is an already option they have, right? You are in the live class, and if you are doing the questions with me here in the class by being in the theory class, that is not for you, right? All right, finished. Okay, now we are going to introduce these terms. Now you can do this way, you can do this way. Now when it comes to the introduction of these terms, you can do the introduction of these terms below that column. I think that is more clear, because the reason is here we have capital T, that is about tension, but in this case capital T is absolute temperature, right? Same label but two different meanings. Same label but two different meanings. So therefore, I recommend you to do like this. You can do the respective introduction below the respective column. You can do the introduction of terms below the respective column, right? Okay, here capital T. Here introduce capital T. Capital T. Tension of wire. Tension of wire. Tension of wire slash string. Tension of wire slash string. Tension of wire slash string. Right? Then simple M. Simple M. Simple M. Mass per unit length. Mass per unit length. Mass per unit length. Right? Mass per unit length. Within brackets, linear density. Linear density. Mass per unit length is also called linear density. Right? Mass per unit length is also called linear density. Within brackets, linear density. Not density, linear density. Linear density. Right? Okay. Then rho, sorry, y. Sorry, rho. Density. Rho density. Right. Then capital A. Capital A will come like this. Right? Capital A. Capital A. Cross-sectional area. Capital A. Cross-sectional area. Now accessing recordings through the website is also very easier. Right? So I think now all of you are familiar with it. Right? Now today I didn't get any inquiries about the website or anything before joining the class. So I guess you are familiar. And about getting recordings also, that is very easy. Payments, that is easy. Everything is easier there, right? So now, since you are familiar, you can make use of it moving forward. And there's another announcement, right? There's another announcement. Now we have missed spot exams from circular motion, as I can remember. Was it circular motion? Circular. Online students, was it circular motion? Circular motion. Did we write circular motion? No, no. We wrote rotational motion. Have we written circular motion? No, no. Rotational motion, you have written, no? Online students, what's the last spot exam you have written? I will check again with my database. Rotational motion you have written, right? Rotational motion you have written, isn't it? Online students? Anyone please confirm? Because I was going to say a good news. Please confirm. Couldn't remember? Then am I the only one who can remember? Huh? Yeah. So the last spot exam you have written is rotational motion, right? And we have you have not written a spot exam from circular motion onwards, right? My website was also developing at that stage, and now it's everything is done. And for 27 batch, 27 new batch actually. For 27 new batch, I have already conducted an exam as well. So now it's properly working, totally finally working. Sorry for late because I had an unexpected meeting in school today. Okay. So please get the recording for the previous part. Now it's 4:47, which means it's 1 hour and 20 minutes. We have started, right? Yeah, either. So please get the recording and cover the parts. No need to get the recording. If needed, you can. Now today, this is on YouTube. You can just go back to the YouTube video, and if you are in the YouTube, if you are watching the YouTube video, you can go back and see it as well. No? All right. All right. So now, since the website is done, exam conduction is also done through the website, and all missed spot exams are coming up, right? So therefore, sometimes you might have to write 2 spot exams on the same month, right? So get ready, get ready. Now I informed today, right? I informed today. First spot exam you are going to get is from circular motion, and then hydrostatics, then hydrodynamics, then simple harmonic motion, right? So these 4 are coming up. These 4 are coming up. Since we have missed spot exam for last month or last 1.5 months, now since I need to get the face back again, sometimes you might have to write a spot exam, 2 spot exams in the same month as well, right? So keep that in mind. Keep that in mind. All right. Okay. Then what is next? Why? Why? Young's modulus. Young's. Young means young. Y-O-U-N-G, young. Young's modulus. Young's modulus. Modulus. Young's modulus. Right here. Introduce G under liquid. Introduce G. G. What is G? Gravitational acceleration. G. Gravitational acceleration. G. Gravitational acceleration. Right. Then H. H. Depth of medium. H. Depth of medium. H. depth of medium, depth of medium, right? Okay, then here gamma, this is not tar, this is gamma. It is written like this, gamma. R is written like this, gamma is written like this. Two different things, huh? Gamma. First one, gamma. Ratio between specific heat capacities. 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 Right? Ratio between specific heat capacities. Look at the board. So gamma is defined as Cp over Cv. Write this and highlight. Cp over Cv. And here Cp refers to specific heat capacity at constant pressure and Cv refers to specific heat capacity at constant volume. Right? That is why gamma is called the ratio between specific heat capacities. Right? So gamma is Cp over Cv. Gamma is Cp over Cv. Gamma is Cp over Cv. Cp over Cv. Right. Then introduce Cp and Cv below. Introduce Cp and Cv below. Cp, specific heat capacity. Cp, specific heat capacity. Specific heat capacity at constant pressure. Specific heat capacity at constant pressure. Specific heat capacity at constant pressure. Then Cv, specific heat capacity at constant volume. Cv, specific heat capacity at constant volume. Cv, specific heat capacity at constant volume. Right? Okay, then capital R. Capital R, universal gas constant. Universal gas constant. Capital R, universal gas constant. Right? Then capital T here. Capital T, absolute temperature. Absolute temperature. Absolute temperature means that is only measured in kelvins. Right? Absolute temperature. Capital T, absolute temperature. And then capital M. Capital M, molar mass. Capital M, molar mass. Capital M, molar mass. Right? Then P, pressure. P, pressure. And rho here, density. Rho, density. Right. So here on this single table, in the single table, you have all the equations we have in A-level physics about speed of a wave, about velocity of a wave or speed of a wave in any media. Right? Next thing. Okay, next thing. As the next heading, write down proving V equals to T over OA. Proving V equals root T over OA using V equals root T over M. Proving V equals root T over OA using V equals root T over M. Right? Okay. Again, tell me what simple M here means. What simple M here means? Not the mass, that is mass per unit length. Simple M means mass per unit length. See, simple M is not the mass, that is mass per unit length. That is mass per unit length. Simple M is mass per unit length, right? Mass per unit length. Now, if I observe these two equations, root is common in both and T is also common in both. So therefore, somehow if we can prove simple M as rho A, which means the equation is done, no? Which means the proof is done, no? Is that clear? If you observe, you can see only difference between these two equations are instead of M here we have rho A. If M equals rho A, if we can prove as M equals rho A, right? Which means it's done, right? So that's my focus. That's a focus I'm going to have, right? This is mass per unit length. How we can expand mass per unit length? How you can expand mass per unit length? Mass per unit length can be expanded as total mass per unit length, no? So it can be expanded as total mass over total length, isn't it? If I need mass per unit length, right? Mass per unit length should be total mass over total length. Is it clear? Total mass over total length, right? Then total mass, let's say capital M, and total length is capital L, right? And now we need to include a density, right? Now we are proving this by using this equation, no? Alright? V equals root T over rho A using this one. So therefore, I'm going to prove M as rho A. I'm going to prove M as rho A, right? So we know, right? We know a very simple equation. Mass can be written as volume into density. Mass can be written as volume into density because density is mass over volume, right? Then you can expand this. M is V rho over L, right? V is a volume. Again, we all know that volume can be expanded as cross-sectional area times length, isn't it? Volume can be written as cross-sectional area times length. That's it. So volume is A times L times rho over L. L to L cancels. L to L cancels. A rho comes. L to L cancels. A rho comes. Right? So which means now I started from here, no? Which means I started from here, simple M. So which means finally what I have got is simple M equals A rho, right? So therefore V equals root T over M equals root T over OA. It is proved. Got it? Right? Simple proofs, but you have to know how it comes. Simple proofs, you have to know how it comes, right? So this is also called linear density. Simple M is also called linear density. Mass per unit length, linear density. Is it clear? Take it down. And I will give the next one to do by your own. So first take this down. Class and for online students also, since the band is released, right? I think you are already aware. Since the band is released, you can also get the band with the next tube delivery, right? So with the next tube, you will get this with the next tube delivery. So then once you have got it, you have to wear it. That is to wear. You have to wear it when you go to classes, when you are going to, I don't know, not to school. From the schools, I think they are prohibited, right? For the schools, they are prohibited. When you are going to classes or maybe, yeah, shopping or wherever, so you can wear it, right? You will get it with the next delivery. Take it down. Okay, finished? Any questions up to here? Any questions so far? Huh? No? Online students? Online students, any questions so far? Is it all clear? Quickly, I need a response. What about you? Clear. Good. Clear. All right. Next proof. Next proof. Write down. Write down. Proving V equals gamma P over rho. Proving V equals root gamma P over rho using V equals root gamma R T over M. Proving V equals root gamma P over rho using V equals root gamma R T over M. Okay. Now, before I start, I will give you some time to try. Right? Try it. Try it. And I will give you a hint. I will give you a hint. Try to use ideal gas equation because R is here. Only equation we have R in it is ideal gas equation. What is ideal gas equation? PV equals nRT, right? PV equals nRT. So try to use ideal gas equation and try it. Give it a try. I'll give you like 2 minutes. Right? And one more thing to know from the Muslim students out here. Now, what's the time you have to pray today? Because with that, I'm going to adjust my break. Tell me. I mean, I don't need the exact time. Just tell me a rough time. 6:00, 6:05, 6:10, 6:15. Likewise, tell me the rough time. Then I can arrange the break accordingly. Right? Six, 6:05, 6:05. 6:05. Okay. Then we'll be having the break from 6 to 6:15. Right? That'll be fine. No? We'll be having the break from 6 to 6:15. Okay. Anyone who has finished? Online? Okay. Who have done the proof? Since you are doing ICT, you don't know vehicles and RT. You don't have vehicles and RT in orders? No? You have? Don't know. If ICD runs, I don't know. the ideal gas equation, that is PV equals nRT. PV equals nRT. Pressure, volume, N is number of moles, R is same as this universal gas constant, T absolute temperature. Right? Okay, let's see. Now, if I observe these two equations again, gamma is common for both, right? So therefore, if somehow if I can prove as RT over M equals P over O, it's done. If I can prove as RT over M equals P over O, it's done, right? That's my target. That's my target, right? For that, I'm starting from this PV equals nRT. PV equals nRT. We know number of moles can be written as mass over molar mass, right? Number of moles can be written as mass over molar mass. So PV equals, this can be written as simple M over capital M RT, right? Then if I cross multiply M, we can write this as PM equals M over V RT, right? But we know rho equals M over V. Right? So therefore, for M over V, instead I can write rho. Then PM equals rho RT. Then we can get PM equals rho RT. PM equals rho RT. Right? In chemistry, the same equation is proved as PM equals DRT. Right? In chemistry, the same equation is mostly proved as PM equals DRT without using rho RT. Right? Here we are usually using rho, right? If you use D also, that is fine, right? That is totally fine. But in physics, we usually use rho. In chemistry, mostly D is used. PM equals DRT, right? Same thing. PM equals rho RT. Now my target was RT over M. Then create RT over M. RT over M. Cross multiply this thing. RT over M equals P over rho. RT over M equals P over rho. Which means this part can be replaced with P over O, right? This part can be replaced with P over O, which means, therefore, gamma RT over M equals gamma P over rho. This is the proof, right? Okay. Make corrections if there's anything. Take it down. If you have got this by your own, that is something to be proud of. Right? Right. Okay. So any questions up to this point? Any questions up to this point? Any questions up to this point? What about online students? No. Okay. So then we are moving on to the next part. We are moving on to the next part. Right. Take down the heading as stationary wave patterns. Stationary wave patterns. Take down the heading stationary wave patterns. Stationary wave patterns. Wave patterns. Stationary wave patterns. Right. Look at here. Okay. When it comes to stationary wave patterns, right? Basically we have four occasions. Basically we have four occasions. Right? Don't write, just listen. First occasion is wave patterns on strings. Right? First occasion is wave patterns on strings or wires. They are same. Strings and wires mean same. And the second occasion is wave patterns on tubes. When it comes to tubes, we have three occasions. Right? It is like this. First one is on wires and strings. Wires, and in the sense wires or strings. That is same. Right? And then we have tubes. Tubes are also called pipes. Right? When we have tubes. In tubes we have both and closed. We have both and closed tubes. And we have both and open tubes. Both and open tubes. And we have one end closed tube. Right? So altogether we have four occasions to be discussed. Altogether four occasions. Got it? Right? Strings and tubes. In strings there is only one occasion, but in tubes we have three occasions as both ends closed, both ends open, and one end open. One end open or one end closed, both are same. No? Either way it's correct. No, one end open, no, one end closed. Right? So these four are the four occasions we are going to look at next. And after these four occasions are done, which means the lesson is covered. The lesson is covered because this lesson is all about these wave patterns, stationary wave patterns. Right? Okay. Let's move on. Let's move on. As the number one, heading number one, as the heading number one write down, heading number one write down, stationary wave patterns in, stationary wave patterns in stationary wave patterns in, sorry, on stationary wave patterns on stationary wave patterns on strings slash wires. Stationary wave patterns on strings slash wires. Stationary wave patterns on strings slash wires. Right? Okay. Look at the board. Look at the board. So this is how we consider. Now, in order to have a stationary wave pattern, in order to occur a stationary wave pattern, the wire should have a tension. The wire should have a tension. Right? So therefore, the wire should be firmly connected between, wire or the string should be firmly connected between two fixed points. Right? So that is how it is. And then to generate a stationary wave in wires, what we do is we can give a small vibration for the wire like this using a finger. A small vibration like this Once that vibration is given, the wire is going up and down like this, right? That is called the stationary wave pattern, right? So when it goes up and down, what happens is that forms due to, now go back to the beginning and think, now that is due to two waves which are propagating into opposite directions, right? We don't see the two original waves to the naked eye, right? But what we will see is the stationary wave pattern, right? So simply to generate this, what we do is you can give a small vibration for the wire, right? So therefore, the first wave pattern is going to be like this. Listen. Now, when it comes to these wave patterns have a nice order, right? Starting from the very first one, and they are developing one by one. So therefore, there's a very nice order, right? A nice order, nice sequence is there, right? And always the gap between two wave patterns are going to be a loop. Now you know what a loop is. The gap between two wave patterns are going to be a loop, right? Okay, and this is how wave patterns are formed. Now we have covered antinodes and nodes up to here. Nodes are the points with minimum or maximum displacement. Antinodes are the points with maximum displacement. Now these 2 points are already fixed. Then they has to be nodes or antinodes. They are fixed. There has to be nodes. Because if the point is fixed, the freedom to move of that point is minimum. Freedom of that point to move is minimum. Got it? Right? So therefore, these two are going to be nodes. And the first wave pattern is the simplest wave pattern. Listen, first wave pattern means the simplest, the primary, simplest wave pattern that can have here, right? Because any stationary wave is like loops I have drawn before. So therefore, here the simplest wave pattern is like this. Simplest wave pattern is like this. 2 nodes here and here, and 1 antinode here. Got it? This is called the first wave pattern, right? So there are more terms for this thing. We will mention all terms as well, right? So therefore, listen, once you draw this thing, to mention the terminology here, you have to keep like 4 lines, right? 4 lines. Now, since this is the first one, I'll write the first one, right? Then second one onwards, you have to keep the space, right? And for these scenarios, don't write, just look at the board. For these scenarios, let's consider the length of the string as L. Length of the string means the gap between the points, L, right? These are the terms used to introduce this, right? So first one is called the fundamental wave pattern. Fundamental wave pattern means the first wave pattern. Fundamental means first, right? So first term, this is called fundamental. Don't write, just look at fundamental or first wave pattern, right? Fundamental or first wave pattern, or it is called the first harmonic, right? So before harmonic, let's come to the overtone. There are 2 types of terminologies used when introducing the wave patterns, right? One is called overtone and the other one is called harmonic. Overtone and harmonic, right? This is how it's getting different. Overtones means overtones are starting from zero. So therefore, fundamental wave pattern is called, this is a definition. Fundamental wave pattern is defined as zeroth overtone. Like this. Zeroth overtone. Right? Zeroth overtone. And when it comes to harmonics, harmonic numbers are starting from 1. 2 definitions. Nothing to think about that. 2 definitions. Right? So with that definition, you have to know the names. That's the purpose here. Right? Harmonics are starting from 1. So therefore, fundamental wave pattern is called the first harmonic. Fundamental wave pattern is called the first harmonic. So therefore, this is the first harmonic. First harmonic. Or this is also called first tone. This is also called first tone. Tone is a similar name, a similar term for harmonic. Tone කියන්නේ same name එකක් similar name එකක්. Right? Especially when it comes to questions are given in overtone or harmonic. Right? Tone කියන එක වැඩි use කරන්නේ නැහැ. I just gave you the tone to you to know that there is something like that, but tones are not that popularly used. Tones are not that popularly used. Always harmonics and overtones are very popularly used. Harmonics and overtones. So likewise, now there is no end for this, right? There can be any number of patterns here, right? Now we are going to check for the first few patterns, and for each pattern this kind of a terminology is coming. So therefore, under each diagram you have to keep 4 lines to write these terminologies, right? So in the first instance, in strings, we will be writing all these things from scratch, and the second one onwards we are not going to write everything again, because that will be same. That will be same for other types of wave patterns as well. So in the first one, we are going to mention everything properly. Got it? Okay. So first take this down as the row number 1. Take this down as the row number 1. Then there is a small calculation part is also involved here. I will come to the calculation next, and listen again. To do the calculation, keep some space in front of this. Here you have to have some space here for a small calculation, right? So don't do like this 1, 2, 3, 4 like this. No, right? Do as 1, 2, 3, 4 1 by 1. 1, 2, 3, 4 1 by 1, because you need this space for a small calculation. Write it down. Any questions? Can you explain again about fundamental wave pattern? Fundamental wave pattern means the simplest wave pattern. It can be formed simplest stationary wave pattern. Now you know stationary wave is consists of loops, right? Stationary wave is consists of loops. So fundamental wave pattern means the simplest loop configuration, simplest form of loop configuration you can have in a given scenario. It's called the fundamental, right? Now, naturally and practically, the nodes and antinodes should be the points with the minimum displacement and maximum displacement. Since these 2 points are firmly fixed, now say this wire. Now, if these 2 points are fixed, which means naturally their displacement is minimum. So therefore, naturally they are nodes, natural nodes, right? So if they are nodes, to create a loop in the middle, there should be an antinode. Otherwise, we don't have a loop. Stationary waves are simply loops, no? They are loops. So likewise, by thinking about that, we can think of the fundamental wave pattern. Fundamental means the simplest pattern, first wave pattern. Finished. Okay. Now let's go to the second wave pattern. Now we will need some space to do a calculation here, right? So therefore, I'll keep the space and going to do the second one here. Okay, second wave pattern. Now in your case, you can maintain the same gap. Listen, you can maintain the same gap for all diagrams. Now, if here you have, let's say, 5 centimeters, then keep the same gap of 5 centimeters and go to the second wave pattern. Okay, listen. When a wave pattern develops, right, always loops are added. Got it? Always loops are added. Half loops cannot be added. Only the loops are added. Loops. Now, here how many loops in the first wave pattern? How many loops? One. Only one. Only one loop. Then in the second wave pattern, how many loops there should be? Complete loop should be added. When it's moving on to second wave pattern, a complete loop should be added. Right? Then how many loops should be? 2. Right? 2. But still, these 2 points has to be nodes. Because they are fixed. Right? Then the only way of having 2 loops is like this, no? Only way of having 2 loops is like this. Got it? That is called the second wave pattern. Half loops adding is not possible. Adding half loop is not possible. Right? Now here, this is also a node now. And this is an antinode. Right? Go to the first wave pattern. Tell me, how many nodes are here in the first wave pattern? How many nodes? 2. How many antinodes? 1. Here, how many nodes? 3. How many antinodes? 2. Right? So likewise, loops are added when the wave pattern develops. Right? Now here, the names are, tell me, now you know. What are the names here? This can be said the second wave pattern. First overtone, second harmonic, second tone. Got it? Okay. Take it down. And try pattern 3. Try the third wave pattern if you finish this. Right? Try the third wave pattern if you finish this. Right? Okay, check again. Okay, check again. Check the terms again. Second wave pattern. Right? Check the names again. Second wave pattern. Right? First overtone. First overtone. Second harmonic. Second tone. Right? Then third one. In third one, another loop will be added. Right? In third one, another loop will be added. So keep the same gap, then you will see these patterns very clearly. Once you keep the same gap. So this is the third one. Nodes, 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 antinodes, antinodes, antinodes. Four nodes and 3 antinodes. Right? Yeah, what are the terms? Names? Third wave pattern. Right? Mention them. Third wave pattern. Second harmony. Sorry, second overtone. Third harmony. Third tone. There's no end for this, right? ඕන තරම් අදින්න පුළුවන්. අපි 4 patterns වගේ ඇඳලා අපි නතර කරමු. Right? ඕන තරම් අදින්න පුළුවන්. There's no end. There's no end. Because we have to prove an equation. We have to prove an equation. Right? That's why. Right? So check the terms again for the third one. Right? Otherwise, now if you have mistakenly switched the harmonic number and overtone number, the whole thing is going to be wrong. Right? So this one, third wave pattern, second overtone, third harmonic, third tone. Right? Then next one. This one. Label nodes and antinodes. Label nodes and antinodes. Node, 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 antinode, 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 antinode. Right? Terms are fourth wave pattern, third overtone, fourth harmonic, fourth tone. Easy, right? Now, once you got this concept, right? Drawing wave patterns is very easy. You have to get this concept. So don't buy hard, just get the concept. Get the concept. Right? Okay, finished? Finished? Okay. Now we are going to link this with, listen. We are going to link this with V equals F lambda. For that we need lambda, right? Now under the differences I discussed, what is the gap between these 2 points in terms of lambda? Tell me. Now if I consider a loop, what is the gap between these 2 nodes in terms of wavelength? What is the gap between these 2 points in terms of wavelength? We discussed before. Lambda over 2. Good. Lambda over 2. Right? Which means one loop is simply lambda over 2. Then if you need half of a loop is lambda over 4. Right? One loop is lambda over 2. Now length of that loop is L, no? L. Which means, look at here, this is the calculation we are going to do. See, here lambda over 2, one loop, right? Lambda over 2, one loop, no, into 1 equals L, right? From this, find lambda. From this, find lambda. Then lambda equals 2L. Lambda equals 2L, right? Go to the board. Then apply V equals F lambda. Then apply V equals F lambda. V equals F lambda, right? Keep V as V. Keep V as V. And there are notations for these frequencies, right? These called the fundamental frequency. These called the fundamental frequency. Fundamental frequency is denoted by F naught. Fundamental frequency is denoted by F naught, right? So therefore, this is F naught times lambda. Lambda is 2L. From this, subject F naught, that is V over 2L. So likewise, what we are going to do is, listen, what we are going to do is, we are going to find the respective frequency of this each wave pattern using V and L, right? So first find lambda and then apply V equals F lambda. Fundamental wave pattern, fundamental frequency is called F naught, which means second wave pattern is called F1, third wave pattern is called F2. So likewise, it goes as starting from F naught, F1, F2, F3, right? And always what we are mentioning here is the overtone number, 0th overtone. Now this is the first overtone, no? So it is written as F1, right? Always with the frequency we are mentioning only the overtone number. That's a standard. That's a standard. That's a rule, right? Okay. Now like this, do the same for these three as well. Very simple, very simple. Do the same for these three as well. Finish? Now 425 batch. Now they have exactly 5 weeks. 5 weeks means now this is Thursday almost, right? So they have 4.5 weeks now for the exam. Just 4.5 weeks, right? So මේ දවස්වල ඉතින් පිස්සෝ වගේ වැඩ කරන්න නැහැ කියන්නේ. අතරම එහෙම තමයි කරන්න ඕනේ. ඉතින් මේ දවස්වල ඉතින් කන්න වෙලාවක් නැහැ, නිදා ගන්න වෙලාවක් නැහැ, එහෙම තමයි. That's the nature, right? You also have to face the same, right? Because this is that much of a significant milestone in the life, right? Sleepless nights, they are normal. Sleepless nights and irregular sleeping patterns, and sometimes not having proper meals, right? So everything is there. But after all sacrifices, you will get the result that value your sacrifices, right? That is how it should be. That is how it should be. Okay, second one. Now always when you are writing, listen, when you are writing the wavelength, use loops and write it out. That will be easier. See, now for the second one, here lambda over 2 times 2 because 2 loops. Lambda over 2 times 2 equals L. 2 to 2 cancels. Lambda equals L. Then apply V equals F lambda. Apply V equals F lambda on C. Okay. Then apply V equals F lambda. Right? And V equals F is F1 now. Lambda is L. Right? So F1 is V over L. F1 is V over L. Right? Then for the next one, mention this as lambda naught, lambda 1, lambda 2 likewise. This is lambda 1, this is lambda 1. Right? Now in this case, it is lambda 2. Here, lambda 2 over 2, such 3 equals L. Such 3 equals L. Right? Which means lambda 2 equals 2L over 3. Again, apply V equals F lambda. Right? V equals, this is F2, lambda is 2L over 3. Then F2 is 3V over 2L. 3V over 2L. And then, let's say this is lambda 3 over 2. Such 1, 2, 3, 4 loops, 4 equals L. Which means lambda 3 equals, this thing cancels, L over 2. Lambda 3 equals L over 2. Right? Okay. Apply V equals F lambda. Right? V equals F is F3, lambda is L over 2. Then F3 equals 2V over L. F3 equals 2V over L. Got it? Correct? Right. Now using these answers, answers for frequency we have obtained, we are going to obtain another equation, right, for nth frequency of the wave pattern. Because now we have to have an equation, a common equation, general equation to get the frequency of any wave pattern. So therefore, we are going to derive an equation now, right? Looking at these answers, we obtain by observing the answers, right? Look at here. Now, if all these answers are obtained, now this is what we have got. I will erase this part. See, this is what we have got. Look at the board. Look at the board. Now stop writing and look at the board. Stop writing and look at the board. We have got F naught. F naught as V over 2L. Right? V over 2L. And we have got F1. F1 as V over L. Right? And you got F2. F2 as 3V over 2L. And F3. F3 as 2V over L. Right? Now, observing these answers, we are going to get Fn. Fn means nth overtone. Right? Now, F naught means which overtone? Zeroth. F naught means zeroth overtone. F1 is first overtone. F2 is second overtone. F3 is third overtone. So likewise, assuming a random n, we are going to get the frequency of nth overtone. Got it? Now looking at these answers, observing these answers, we are going to get that equation, right? See, now to see a pattern here, right? Especially when it comes to human beings, right? Unlike animals, human beings are always capable of understanding patterns, right? Unlike animals, and that's a special feature we have, right? As human beings, Human beings are always very fluent and very qualified when it comes to understanding patterns. Right? අපිට pattern එකක් තියෙනවා ටක් ගාලා ඒක identify කරලා understand කරගන්න පුළුවන්. එහෙම තමයි human beings කියන්නේ. Right? So therefore you have to see a pattern here. You have to see a pattern here. Right? Now 2L is here, no? But here it is only L. Here again 2L. Here again L. Right? So therefore I need to take all of them to the same pattern to observe. So therefore what I'm going to do is I'm going to rewrite this as 2V over 2L. No problem. 2V over 2L. And this is same 3V over 3L. Right? And this is, we can write this as 4V over 2L. No? We can write it as 4V over 2L, is it? Right? Now, can you see V over 2L is common for all? V over 2L is common, no? V over 2L is common. V over 2L is common. Right? Now, can you see the number here changes as 1, 2, 3, 4. When V over 2L is common, that coefficient in front changes. Right? Observe this is understanding the pattern. This is understanding the pattern. So which means I can write this as, see, I can rewrite this as V over 2L times 2. We can write this as V over 2L times 1. We can write this as V over 2L times 3, isn't it? And I can write this again as V over 2L times 4. Right? Now you can see the pattern. Now, which part of the answer is common? Now, my target is writing Fn. My target is writing Fn. Which part of the answer is common? Which part of the answer is common? V over 2L. V over 2L is always coming. V over 2L is always coming. Which means in nth one also, V over 2L should be there. Right? In first 4 patterns also, we have V over 2L. If you check 5th pattern also, you will get V over 2L. Right? Which means in any pattern, we have V over 2L. Then in nth pattern also, you have V over 2L. Right? Then in Fn also, V over 2L. Right? Times, what happens here? What happens here? When this is F naught here, when this is F naught here, 1 comes. When this is 1 here, 2 comes. When this is 2 here, 3 comes. When this is 4 here, sorry, when this is 3 here, 4 comes. When this is n here, what should be here? Human beings are naturally capable of identifying patterns. Right? So tell me, n minus 1. N minus 1. Sorry, n plus 1. N plus 1. Right? 0, 1, 1, 2, 2, 3, 3, 4. Then n plus 1. Right? Always the difference between these two is 1. No? Then this should be n plus 1. Right? So therefore, final answer, we are writing this as n plus 1 times V over 2L. This is called the frequency of nth overtone, of a string. Right? N plus 1 V over 2L. Got it? Now in other occasions also, we are going to do the same. So, right? First we will be getting 4 equations like this, and then after observing equations, you have to come up with the answer for nth overtone. Got it? Right. First mention these 4, only these 4. Mention these 4 quickly. Only these 4. Don't write the equation in black, right? Only these 4. Mention these 4. Mention these 4. Only these 4. Only these four. This is pattern identification. Pattern identification. Now in this part there is no math behind it. Identify the pattern as a natural human being. අර තියෙන grade 5 scholarship එකේ patterns දන්නවනේ number patterns තියෙන්නේ 1 3 5 7 you are asked to predict the next number in the pattern right මොනවද තියෙන්නේ තව තියෙනවනේ 1 4 9 ඔහොම ගියේ අර patterns you know right 1 4 9 16 25 ඒකත් එකක් so likewise you have to identify the patterns now you are learning identifying patterns since grade 2 3 or something because you have grade 5 scholarship exam questions from patterns number patterns මේ pattern එක right okay then after this mention this in red therefore frequency of in red therefore frequency of simple nth overtone therefore frequency of like this nth therefore frequency of nth overtone therefore frequency of nth overtone of a string is therefore frequency of nth overtone of a string is put a comma and now write this down and highlight the final equation highlight the highlight the final equation right then below the equation introduce terms below the equation n tell me what is n overtone number n overtone number if n is overtone number what is n plus 1 if n is overtone number what is n plus 1 harmonic number because harmonic number is always 1 higher than overtone number if n is overtone number n plus 1 is harmonic number right sorry tone right but we don't say tone number right we say harmonic number same I mean we can say but popularly using overtone and harmonic right that's why I mentioned both most popular terms are overtone and harmonic can also be said as tone right then mention n overtone number n is overtone number n plus 1 harmonic number then l length of string then v velocity of stationary wave through string velocity of stationary wave through string okay then tell me if velocity of stationary wave through string is v what are the equations of v we can use here therefore v equals tell me what are the equations of v we can use here that is the velocity of wave through the string. From our mediums, tell me, when it comes to string, is it a solid or a liquid or a gas? The string? Solid, liquid or gas? Solid. Then V should be the velocity of the stationary wave through the solid medium. In strings, we have transverse waves. So therefore, this V is either root T over M or root T over OA. Got it? Right? So at any time you can expand V as this, because this is a stationary wave on a string. On a string means that's a solid medium. On strings we have transverse waves. Then solid transverse. These are the equations can be used. That is why we mentioned all equations in that table before, right? Okay, mention in red again. Therefore, V equals root T over M or root T over OA. Therefore, root V equals root T over M or root T over OA. N over 1. N is odd number, n plus 1 is harmonic number. Right? Okay, then below this mention, moreover, Fn can be written as, Fn can be written as follows using fundamental frequency. Moreover, Fn can be written as follows using fundamental frequency. Fn equals, see, now what we have proved is Fn equals n plus 1 times V over 2L now. But V over 2L is what? Fundamental frequency. So therefore, this can be always written as Fn equals n plus 1 times fundamental frequency. Right? Write this one as well and highlight. See, that's the relationship between these frequencies. Which means if the fundamental frequency is, let's say, 10 hertz, right? Then this frequency is going to be 20 hertz, 30 hertz, 40 hertz, 50 hertz, 60 hertz. So likewise, it goes on. So therefore, Fn can be written as n plus 1 times F naught as well. Next point. Therefore, respective frequencies go as below that. Therefore, respective frequencies go as F naught, 2F naught, 3F naught, 4F naught, 5F naught, and so on, like this. Right? Again, next point, using a red pen with an asterisk mark, write down harmonic number gives harmonic number gives the multiplying factor of any given frequency, with respect to fundamental frequency. Harmonic number gives the multiplying factor of any given frequency with respect to fundamental frequency. right? So which means it is like now f0, 2f0, 3f0, which means see this is the harmonic number. Harmonic number here is 2. Harmonic number here is 3, 4, 5. It gives the multiplier of f0. Right? The idea is a given frequency is how many times of the fundamental frequency is the harmonic number. A given frequency is how many times of a fundamental frequency is the harmonic number. Right? Okay. Any questions up to this point? Quickly. Now it's 6, 7. I think I have to give the break. Any questions up to here? Quickly. No? All good? Online students? Zoom, YouTube? What about you? Any questions? What about the ones on YouTube? Any questions? Quickly. No. All right. Then now it's 6, 7. Now we'll be getting the break, right? So you can come back to the class by I'll give 15 minutes by 6:23, right? So this is the interval, the break, right? Now it's 6, 8 now. 6, 8 and come back by 6:23, right? Okay. All right. Go and refresh yourself and come back, right? If you are having something, you can have a small meal, a snack, and if you are praying, you can pray, right? If you are having something, have it and refresh yourself, wash your face, right? And break your ice and come back to the class again by 6:23, let's say. Okay. See you. Right. Okay. Okay, I hope you have come back. Hope you have come back. And I'm audible, right? Okay. Right. Online students, are you there? Online students, are you there? Right. I will give you 2 minutes. Go through this thing again. This thing in the sense, go through the derivation of this equation of Fn again for the stationary wave patterns on strings, because now we are going to move on to the other occasions, right? On tubes. But same knowledge will be used, right? So therefore, from stationary wave patterns on strings, go through quickly. I will give you 2 minutes and go through quickly what you have done. Drawing wave pattern and the names means terminology, and then calculation part, and finally the derivation of equation. Right? Okay. So now we are moving on to the second occasion. What is the second occasion? I explained. I just said, not explained. I just said. What is the second occasion? Second one, stationary wave patterns in tubes. Tubes are api mulimang close in. Right? Okay. As number 2, write down. Number 2, write down stationary wave patterns in. Stationary wave patterns in. Stationary wave patterns in both and closed tubes. Stationary wave patterns in both and closed. Both end closed tubes. Stationary wave patterns in both end closed tubes. Stationary wave patterns in both end closed tubes. Okay, now you know what tubes are, right? Right. So tube means like this. See, just look at the board. The tube is like this. Something like this. This is called a tube. This is called a tube. Right? Like this. If both ends are closed, this is called a both end closed tube. Right? If both ends are closed, that is called a both end closed tube. Right? Now, when we are doing wave patterns, we are not going to draw the tube like in a 3D manner. We are going to draw the tube in a 2D, right? So just know what a tube is. Okay. So first wave pattern. So let's assume this tube. Now this is a closed tube. This is a closed tube, right? Okay. Listen. Now in the string, we know the vibration was with the string, right? So about the string, the vibration was with the string and the wire or the wire, right? Now here, what is going to be vibrated? This is a tube. Both ends are closed, and inside the tube we have an air medium. Inside any tube we have air, no? So inside the tube we have an air medium. Now, which medium is going to be vibrated in the tube? Is it tube or air? Is it tube or air going to be vibrated here? Any thoughts? Any thoughts? Tube. Yeah. Yeah, we are getting both answers. We are getting both answers. That is actually, yeah. Tube will be same as it is. Tube is fixed. Tube will be same as it is. And the air medium inside tube is going to be vibrated. Right? Now, as an example, usually sounds are formed. As an example, flute. Flute can make it. In flute, the air medium is vibrated. That's a stationary medium, stationary wave there, right? Flute, trumpet, right? Air medium. And for strings, for stationary wave patterns on strings, violins, guitars, what else? Sitar, okay, strings වලින් vibrations වලින් guitar, කොට පස්සේ bass guitar ඕන එකක් හරි, guitars, then violins. ඊට පස්සේ අර sitar එක කියලා තියෙන්නේ. දන්නවද? sitar එකත් හරි. What else? තවන්න තියෙන්නේ. අන්න වීණා කියන එකත් හරි, right? So any instrument which is having strings has stationary wave patterns on the strings, and the instrument which has vibrations of air, right, has stationary wave patterns on air. Popular examples are flutes, trumpets, then mouth organs. So පොඩි පොඩි ගොඩක් තියෙන mouth organs. ඊට පස්සේ මොනවද? Saxophones. ගොඩක් තියෙනවා. Saxophones. What else? Right? So anything, right? ඒ වගේ. So air medium is going to be vibrated. Air medium. හරි මේක නිකන් flute එකක් වගේම තමයි. මේ flute එකක්ම තමයි. Right? Now, naturally, tell me, just thinking about the natural motion of air particles, tell me, because now air is going to be vibrated, where we can expect notes and at which point we can expect antinodes, because my first target is determining the or coming up with the first wave pattern. My target is coming up with the first wave pattern, that's why. Then second wave pattern. Tell me, at which point we can expect nodes and which type of points you can expect antinodes? That is my first question. Refer end and middle or center. Tell me, nodes. Where can we expect nodes first, not the antinodes? Where can we expect nodes first? Endpoints or the center point? Nodes. Think of the natural motion of air medium which is going to be vibrated here. And tell me. Quickly. Just tell me. What about online? No idea? What about online students? Any idea? In the middle, nodes or anti-nodes? Nodes. Online? Just tell me your thoughts, that's fine. If you went wrong, you will learn now. Right? I'm just asking. Ends. So at ends, the movability of air particles is minimum at ends because that is in contact with or it's colliding with the wall. It's colliding with the wall. Wall at the collide with the are moving right? So if that is fully free all around, then the moving ability is higher. Such points are antinodes, right? So therefore, here also endpoints are going to be nodes. Endpoints are going to be nodes. So the first wave pattern is like this. First wave pattern is like this. So let's consider the length of tube as L. Let's consider the length of tube as L. Right? So the first wave pattern is like this. And here we have nodes, and antinodes. Right? Now, listen. The terminologies, terms, names are also going to be same. This is called the fundamental wave pattern, first wave pattern, then zeroth overtone, first harmonic, first tone. Right? Same. That is same. So if you are mentioning names, you can mention the names here. Same as before. Same as before. Otherwise, you can just write it as same. That is same. Same as before. Right? And when it comes to the second one, another loop will be added. Third one, another loop is added. So likewise, now listen, you have a small task. Listen, starting from the first one, first thing, draw the wave patterns, right? And do the labeling, and then do the calculation and determine F0, F1, F2, F3, right? And still, if you got some time, then derive Fn, right? Start. Now, once you know this, you can easily do this and proceed. Right. Finished? Finished? Okay. Check your answers. Check your answers. Second one loop should be added. No, one loop. Then here, two loops like this. Here, another loop should be added. Then three loops. Here, another loop should be added. Then four loops. Right? Right? But still, length remains same. We are considering the same tube. Right? Then the calculation part. Finished? Okay, then first one, a loop is lambda over 2. Very simple. Let's say lambda naught here. Lambda naught times lambda naught over 2 times 1 equals L. So lambda naught equals 2L. Then apply V equals F lambda. Right? Then V equals F naught. Lambda is 2L. F naught is V over 2L. Right? So likewise, you can prove all F naught, F1, F2, F3. Finished? This is very much similar to the previous one. Lambda over 2 times 2 here. That is also L. Then lambda 1 equals L. Right? Same thing. Apply V equals F lambda. V equals F1. Lambda is L. F1 is V over L. Right? And this one, lambda 2 over 2, such 3 equals L. So lambda 2 equals 2L over 3. V equals F lambda. Right? Then V equals F2 lambda is 2L over 3. F2 is 3V over 2L. And last one, lambda 3 over 2 times 4 equals L. Lambda 3 equals 2L. Then V equals F lambda. V equals F3. Lambda is 2L. So F3 is V over 2L. Right? Same answers as before. Exact same answers as before. Which means Fn is also going to be same, no? Is that clear? Since they are same answers as before, Fn is also going to be same. Right? Same. Right? So therefore, since it is same, I'm going to derive it at once. Right? I explained the method in the last one. So therefore, I'm going to derive it at once. So after all, write down, therefore, frequency of nth overtone of, therefore, frequency of nth overtone, of a closed tube. Now, when it says closed tube, by default, we consider both and closed tubes. Closed means both and closed. Right? Open means both and open. One and close or one and close means one and. Right? Am I considering that? Right? So, therefore, frequency of nth overtone of a closed tube. Put a comma and write down the equation of nth overtone. That will be same as before. Fn equals n plus 1 V over 2L. And highlight the equation again. Right? Introduce terms again. N, you know these things now. N, overtone number, n plus 1, harmonic number. L, length of tube. Right? N, overtone number. N plus 1, harmonic number. L, length of tube. Right? And V, what about V? V is velocity, that is true. But this is through which medium? Through which medium? Air medium. Because air is vibrated now. Right? So V, velocity of wave through air medium. Velocity of wave through air medium. Velocity of wave through air medium. You missed, right? No, right? L and V will be different because L is length of tube and V is velocity of wave through air medium. V, velocity of wave through air medium. Right? Okay. Therefore, tell me, what are the equations of V now? Now, air medium is vibrated. Then V is either gamma RT over M or gamma P over O. V is either gamma RT over M or gamma P over O. Right? Now, this is coming from the table. Now, here, air medium is vibrated. Since air medium is vibrated, now that is actually longitudinal because in air mediums, we only have longitudinal waves. So, longitudinal equations, these two. Right? So, that is how the equations are getting different now. Now, just by the look here, equation is same. Only V is different. Only the V is different. Is it clear? Right. Then mention, therefore, in red, therefore, V equals these two. In red, therefore, V equals these two. Therefore, V equals these two. Clear? Then again, moreover, Fn equals n plus 1 F naught. Highlight this thing as well. Moreover, Fn equals n plus 1 F naught. Now, all these equations will be needed when we are going to application sums. Next day, we are starting sums, right? So, therefore, by the next day, You have to remember all these equations. If not, now definitely you will get stuck when I discuss the sums. Because today, now we are going to finish theories. After finishing theories, next day straight away we will be starting sums. Right? Then all this knowledge you gain should be there. Right? Okay. Finished. Moreover, put a comma and mention this. Right? Okay. Then that is all about the closed tubes. That is all about the closed tube. Then again, we are going to move on. Okay, before that, any questions about closed tubes? Any questions about closed tubes? Need a quick response. Sorry? In tubes? Sorry, I don't get you. In tubes, it's only a. It's only a. Right? In tubes, only a. No questions? Okay, then third instance, number 3. Number 3. Number 3. As number 3, write down the stationary wave patterns. Number 3, stationary wave patterns. Stationary wave patterns. Number 3, stationary wave patterns in both end open tubes. 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 Right? Okay. For further, it should be L over 2. I didn't get your question. Can you rephrase and send it again? For further, it should be L over 2. What does that mean? I didn't get your question. What to ask? For F3, it should be L over 2. For F3. Yes. Sorry. Sorry. Yeah. For F3, L over 2. Yeah. Okay. Thanks. Okay. Then next type. Next type. Okay. Open tubes. Now this is how an open tube look like. Both ends are open. This is how an open tube look like. Open tube. Right? Right. Now inside an open tube also we have air. Inside an open tube also we have air inside. Right? So air medium is going to be vibrated. Air medium is going to be vibrated. It's clear now? Right. Now tell me, now considering the endpoints and center points, tell me at which kind of points you can expect nodes now and which kind of points you can expect antinodes now. What's the thought now? What's your opinion? What's your idea now? Tell me. Just your thought. In the chat, we have some answers. Nodes at center, antinodes at ends. Exactly, yes. Exactly, yes. Right? Because now compared to the center points, endpoints are open. Compared to center points, endpoints are open. Since endpoints are open, the mobility is high. Right? Endpoints are open. So therefore, mobility of the air particles inside endpoints are higher compared to the middle points. Therefore, now comparatively endpoints are highly movable. Therefore, at endpoints now, we are going to get antinodes. At endpoints antinodes now, see, now before drawing the pattern, just observe, now here we will get antinodes. Here also you will get antinodes. And at the center, there should be a node, right? Then, can you see, if this is a node and if this is an antinode, a whole loop is not going to be formed now. Got it? Understand the concept. A whole loop is not going to be formed now. Only a half of a loop is going to be formed. Therefore, first wave pattern here is like this. First wave pattern here is like this. However, it started, when developing the wave patterns, only whole loops can be added. Half loops add when the bad. Got it? It started with the half loops, but when the wave patterns are developing, half loops cannot be added. Half loop cannot be added. Then in the second wave pattern, a whole loop will be added here. A whole loop will be added, right? So this is the first wave pattern. Give it a try. Try to draw the second one. So let's consider length of this as L as usual. This is the first wave pattern. Try to draw the second wave pattern. Try to draw the second one. And the third one, fourth one. Try it. Yes, half loop means L over 4. Half loop is L over 4. Good. Half loop means L over 4. One loop is L over 2. Can you explain again? Now, this is determined by the relative displacement or the relative ability of displacement, right, of the gas particles. Now, compared to middle points, endpoints are more open now. They have more freedom than middle points. So therefore, compared to center points now, endpoints are open. Since endpoints are open, they are going to be antinodes now, right? So compared to the endpoint, center points are now minimum in displacement. That is comparative. That is comparative. Now, if you compare the same instance with the previous one, in the previous one we had both end closed. Now, with the closed end, the mobility of particles are very much low. But here in the open end, mobility of particles are very much high. So likewise, with respect to that, it changes. Is it clear now? That is how you should identify the first pattern. Once the first pattern is identified, then developing other patterns is not going to be that much difficult. That is easier because you know the pattern, how it goes and how it goes in the sequence. So this is the concept we have. This is the argument we have. Is it clear now? Aida, is it clear? Try to draw the other patterns. Try to draw the other wave patterns. Yes, okay, good. right? What about the second wave pattern? Wrong. Why? In two consecutive wave patterns, the difference is only by a loop, a whole loop. Now in your one, two loops added, isn't it? Then that is not the second wave pattern. Only one loop should be added, because always the difference between two consecutive wave patterns is a loop. I told you, when it develops, a loop will be added. When it develops, a loop will be added. So add a loop. And for the next one, add another loop. Then next one, add another loop. So likewise, difference is a loop. Right? So what about the second one? A loop should be added. So what happens? Like this. See, a complete loop is added now. Then for the next one, add another loop. And for the next one, add three more loops. Add three more loops like this. Can you see? Right? For this one loop is added. Then two loops, three loops. Always the difference between two consecutive wave patterns is a loop. Is a loop. Loop back change loop back right? Then what about the names? What about the names? Now here, listen. Now here, this is called the what? Fundamental wave pattern or the first wave pattern. Zeroth overtone, first harmonic, first tone. Got it? අර ගානට ඕඩ එකට තමයි යන්නේ. Sorry? This is first harmony. Same as the previous two. First harmony. right? Then do the calculation. Now here, listen. Now here, when you calculating lambda, since this is a form of half loops, you better use lambda over 4 multipliers. Now as an example, if this is lambda naught, this is lambda naught over 4, such 2, is it clear? Equals L, which means lambda naught equals 2L. Got it? Now for the second one, lambda 1 over 4, such how many? 1, 2, 3, 4. Right? Half loops are only with 4, 4 half loops here. Right? Equals L. So lambda 1 equals L. And here lambda 2 over 4, such 1, 2, 3, 4, 5, 6. 6 equals L. Right? Again, lambda 2 equals 2L over 3. Lambda 3 over 4, such 1, 2, 3, 4, 5, 6, 7, 8 equals L. Lambda 3 equals L over 2. These answers are also same. Right? Now, as a trick, just know that when you have half loops, always it is easier to use half loops when you are writing the length. Right? Like lambda over 2 plus lambda over 4 plus lambda over 4. No. Just write it as lambda over 4 times so. Got it? And prove all these 4. And same thing again. Questions? Let's see. Can you explain how did you get lambda over 4? Because one loop is lambda over 2. Right? Now, I explained it from the beginning of the differences. One loop means this is lambda over 2. One loop is lambda over 2. If one loop is lambda over 2, this is half of a loop. Then half of a loop is lambda over 4. Right? Very simple as that. Simple as that. Clear? You were not there at the beginning. Okay. Right. I just forget it. Right. Then write down, therefore, frequency of nth overtone, therefore frequency of nth overtone, therefore frequency of nth overtone of an open tube, therefore frequency of nth overtone of an open tube, therefore frequency of nth overtone of an open tube. Right? Of an open tube. Put a comma and take this down again. Right? And here also, I'm not going to introduce all these terms again because that is same as previous. No, here mention it as all terms are same as previous. Right? Mention this. All terms are same as previous. Mention it here. All terms are same as previous. So no need to write again. Just mention that sentence. All terms are same as previous. All terms are same as previous. All terms are same as previous. Right? Again, write down this thing using red. Therefore, V equals, these also are mediums, no? Same. Therefore, V equals root gamma RT over MO, root gamma P over O. Therefore, V equals root gamma RT over MO, root gamma P over O. Right? Root gamma RT over MO, gamma P over O. Then moreover, the same thing again. Moreover, Fn equals n plus 1 F naught. Right? Moreover, Fn equals n plus 1 F naught. Fn equals n plus 1 F naught. Right? Okay, now we are moving on to the fourth occasion. 4. Occasion 4. And you better put an asterisk mark for this fourth one because this is having some differences. You better put an asterisk mark for the fourth one. Fourth occasion. Write down stationary wave patterns. Heading 4. Stationary wave patterns. Stationary wave patterns in one and closed tubes. 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 Right? Okay. What is a one and closed tube? One and closed tube is like this. Only one end is closed. Like this. Got it? Only one end is closed. Okay, now again, use your knowledge and think and tell me, in a one and closed tube, what can you say about the positions of nodes and antinodes? Think and tell me. What can you say? We will consider the length as L. Tell me. Now, these ends are not identical now. Ends are not identical. One end is closed, one end is open. What's the point with the minimum displacement? Closed end or open end or middle? Closed. Right now, there are 3 possible points you have to pay some attention of. The endpoint, right? Endpoint means the closed end or the open end or the center. What do you say? What is the most probable point to have a node? Closed. Online students? Zoom, YouTube, what do you say? What is the most probable point to have a node? Quickly. What is the most probable point to have a node? Yes, yes, it is closed end. Then most probable point to have an antinode is the open end. Now, which means node here and antinode here means again there is not a full loop, there is only a half loop. Right? That is the first wave pattern. Now, in the second wave pattern, another whole loop will be added. Next wave pattern, another loop will be added. Fourth wave pattern, another loop will be added, and it goes on. Right? Okay, do the same again. Do the same again. Right? Here we will be writing the names again because here there is a difference. Here there is a difference. So therefore, you better mention all names again. You better mention all names again. You better mention all names again. Can you explain again? Now always nodes and antinodes. Formation of nodes and antinodes is with the relative displacement of these particles. Compared to an open end, a closed end is having a minimum displacement, which means for the are particles which are at the closed end, since that is closed, displacement is minimum. So therefore, such points are nodes. and the point with the maximum displacement, maximum possible displacement are the antinodes. So likewise, we have to decide on nodes and antinodes. Right. Now here first one, this is called what? This is fundamental wave pattern. Fundamental, which means first wave pattern. Right, first wave pattern. And this is the zeroth overtone. Zeroth overtone. Right, first harmonic and first tone. First harmonic and first tone. Right. Keep some space for other names because I will come to the names again after proving the equation. That you will see from the equation. Now, what about the second pattern? Second pattern should be a loop is added like this. A loop is added. In the third pattern, two loops are added like this. Two loops are added like this. Correct? Correct, right? Yes, good. Correct? Then the next one, 2, 3 loops are added. 1, 2, 3 loops are added. Right? Then prove the equation. Prove the equation. Okay. I'm doing the respective calculation of the first one here. First one is lambda naught over 4 such 1 equals L. So lambda naught is 4L now. Apply V equals F lambda. Apply V equals F lambda. V equals F naught. Lambda is 4L. So F naught is V over 4L. First one. Right? Then the second one, let's say lambda 1 over 4 such 1, 2, 3. 3 half loops equals L. So lambda 1 equals 4L over 3. Lambda 1 equals 4L over 3. Then V equals F lambda. V equals F1 and lambda is 4L over 3. So F1 is 3V over 4L. 3V over 4L. Then next one, lambda 2 over 4. Such how many? 1, 2, 3, 4, 5 equals L, which means lambda 2 equals 4L over 5. Apply V equals F lambda again. Then V equals F2 lambda. Lambda is 4L over 5. So F2 is 5V over 4L. Last one, lambda 3 over 4. Such 1, 2, 3, 4, 5, 6, 7 equals L. So lambda 3 equals 4L over 7. Apply V equals F lambda. Same thing. V equals F3 and lambda is 4L over 7. So F3 is 7V over 4L. 7V over 4L. Right? Check your workings. Understood? Same pattern continues. Same patterns. In second instance, why did you multiply by 3? Because 3 half loops, no? Okay? මේ half loops පේන්නේ නැත්තම් මෙහෙම ඇඳලා බලන්න මේ 1 2 3 මෙතන half loops ගත්තම 1 2 3 4 5 right මෙයා ගත්තා නම් 7 number of half loops. What do you ask? Half loops, number of half loops, because I'm writing in terms of lambda over 4 now. When we have half loops, writing in terms of lambda over 4 is easier. That's why. Understood? Right. Now, after all these proofs, now prove Fn. That is the thing here. Now you have to identify the pattern. See, these are the equations you have got now. These are the equations you have got now. F0 equals V over 4L. F1 equals 3V over 4L. F2 equals 5V over 4L. And F3 equals 7V over 4L. Now, if you rewrite this way, can you see what has happened? This is 1 times V over 4L. This is 3 times V over 4L because V over 4L is common. This is 5 times V over 4L. And this is 7 times V over 4L. Got it? Then in nth one also, V over 4L should be common. In nth one also, V over 4L should be common. That's coming in all the answers. Then in nth answer also, it should be there. Right? So identify the pattern. Then Fn equals V over 4L is there for sure. For sure, V over 4L is there. What has happened here? When you have 0, 1 comes here. When you have 1 here, 3 comes here. For 2, 5 comes. For 3, 7 comes. Then for N, this should come. Think and tell me. Human beings identifying wave patterns. Identifying patterns. Tell me. What do you say? And thus, check whether it matches. If you put 1, no. What do you say? Online. Yes, it's 2n plus 1. I got the answer. It's 2n plus 1. It's 2n plus 1. So therefore, this is 2n plus 1. Odd number series. Right? Grade? I don't know. You just think of the grade. 2n plus 1. Right? Okay. Then after this proofs, right? Again, write these 4. Only these 4. Write these 4 quickly. Mention these 4. Only these 4. I'll be erasing this. Right? Then write down therefore frequency of nth overtone of frequency of write down frequency of nth overtone of an 1n closed tube. Therefore, frequency of nth overtone of an 1n closed tube. Put a comma and write down this. Fn equals 2n plus 1 V over 4L and highlight the equation. and highlight the equation. Right, and here I will introduce these two again, n 2n plus 1 now, because that is getting different. What is n? That is as usual, n is odd odd number. N is odd odd number. I told you harmonic number is the multiplier of f naught, which means how many times of f naught means harmonic number. So therefore, in this case, 2n plus 1 is the harmonic number. That is the difference. Right? Write down it very clearly. This is overtone. This is the overtone number. And this is now harmonic number. And this is now the harmonic number. Got it? Right? So inside this thing also, we have an air medium. Therefore, mention this. Therefore, V equals these two again, gamma RT over MO root gamma P over rho. And then moreover, Fn equals, now that is 2n plus 1 times F naught, highlight this. 2n plus 1 times F naught. 2n plus 1 times F naught. Clear? Right? So below this, write down, therefore, respective frequencies go as, write down, therefore, respective frequencies go as in red, therefore, respective frequencies go as, can you see, first one is F naught, and second one is, if you put 1 here, 3F naught, and the next one is 5F naught, 7F naught, 9F naught, and so on and so forth. Got it? Only the odd numbers are coming now. So this is the different scenario. Compared to all three scenarios before, this is different. Only the odd numbers are coming. Only the odd numbers are coming. Listen now. I'll give a small task as a homework. So listen. Right? Frequencies go as this. Right? Listen. Now, this is the harmonic number. Oh, this is the harmonic number. So therefore, now when you are labeling the second one, listen. I'll check on the next day. Now this is the first overtone. First one is make a first wave pattern. This is second wave pattern. එකක් ලියලා පෙන්නන්නද? මෙන්න බලන්න. එකක් ලියලා පෙන්නන්න. Look at here. I'll be writing only one. මේක ලියලා පෙන්නන්න. This is the second wave pattern. Second wave pattern. And this is the first overtone. But the harmonic number is 2n plus 1. So therefore, this is going to be what? This is going to be the third harmonic. Second harmonic කියලා එකක් මේකේ නැහැ. No second harmonic here. That is the third harmonic. කෙලින්ම එන්නේ F naught, 3F naught, 5F naught. 2n plus 1. Third harmonic and third tone. Fifth harmonic, seventh harmonic, ninth. Likewise it goes. Right? That difference is there. So understand it and complete all the labeling here when coming in next day. Right? Okay, now from here actually all the theories of stationary waves are over. Right? So that's why I went a little bit faster in the last part, because to cover all the theory parts, otherwise no point of having a small residual remaining. That's why. Right? Any questions? Any questions from the parts we covered? 734 or 35. Any questions from the parts you covered? All good? Online students? What about you? Any questions? Now this is the first time you had a 4-hour class with me. In that mechanics seminar, you were there around more than 6 hours, right? Yeah, more than 6 hours, around 6.5 hours. Yeah. Yeah. No questions? Okay then. So if there are no questions, we'll wind up here. So next day, I'll be starting all the questions, sums of stationary waves, right? And by next day, we are going to finish this off, right? Go through these things again and be familiar with these things and be comfortable with these things and come to the next class, because all this knowledge will be used when you are doing the questions, right? Is that clear? All right then, and label these labelings. All right then. Then we'll wind up here. See you all in the next day. Go safe, physical ones, and all of you stay safe and study hard, work hard. See you all in the next class. Good night and goodbye. See you.